In section 4.6, which is our last section of the chapter, we're going to solve systems of linear inequalities. On page 271, look at the gray box in the middle of the page. A system of linear inequalities is made up of two or more linear inequalities. A solution of a system of linear inequalities is an ordered pair that makes all of the inequalities in the system true. The graph of the system of linear inequalities is the set of points that represent all of the solutions of the system. Here is your essential understanding. You can graph the solutions of a system of linear inequalities in the coordinate plane. The graph of the system is the region where the graphs of the individual inequalities overlap. So basically, here's what you're doing. You're solving a system. The system involves inequalities, not equations. Equations, you could use substitution, you could use addition method, you could use graphing. In an inequality, you have multiple answers. So there are millions and millions of those answers. So there's no way that you could write down those answers. So your graphs are going to represent your answers. You're going to find where the systems overlap. So you're combining what you did in section 4.5 and doing just two of those in one graph. So we're going to start with problem 1 on page 271. All right, so we're going to graph both of these. So the first one we're going to graph is y is greater than or equal to negative x plus 5. So if we graph using slope and y-intercept, we're going to put a dot on 5. And our slope is negative 1, so we go down 1 to the right 1. Because it's greater than or equal to, I'm going to have a solid line. And because it's greater than, I'm going to shade above the line. Now once again, you could plug in 0, 0. And if you plugged in 0, 0, you get 0 is greater than or equal to 5, which is not true. That means this point 0, 0 is the not true side. We need to shade the true side, which is up here. In the second inequality, I'm going to solve it for y first. Add 3x to both sides. And I'm going to use a different color. I would highly suggest you use a pen or pencil, or two different colored pens, or two different colored pencils. So negative 4. My slope is 3 over 1, so I'm going to go up 3, 1, 2, 3 over 1, up 3, 1, 2, 3 over 1. It is also a solid line because the boundary line includes solutions. Now, notice I have an arrow here. I want to go a little further because it's going to match my region here with my green region. So because this is less than would be on this side because that's below the line. Now, once again, we could have plugged in 0, 0, which gives me that. 0 is not less than negative 4, so that means the true side is on the right, which is kind of underneath. So my solution, my final answer, is going to be the region that overlaps, which is this. So this right here is my actual answer. There is no way that you could list all of the answers in this region that makes it true. But this region, so you can darken it, all the answers, all of the points that are in that region are solutions. Example number 1 on page 272. I'm going to graph the first one in red, so that's already in slope-intercept form. Y is less than 2x plus 4. So 1, 2, 3, 4. Up 2 over 1. I'm out of room here, so I'm going to go down 2 over 1. It's still going to be positive. It does not include a less than, so therefore it's dotted. That means any solution on the line would actually not be a solution. So any point on the line is not a solution. Because it's less than, I'm going to shade underneath. All right, next I'm going to solve the next one for y. Negative 2y is greater than or equal to 3x plus 6. I now divide everything by negative 2, and this is something I'm hoping you remember from last year. Because you divided by a negative, the inequality flips, and you're going to get negative 3 halves x minus 3. So I'm going to graph this in blue. So negative 3, down 3 over 2, and I'm going to go up 3 to the left 2. Up 3, 1, 2, 3 to the left 2. It's going to be a solid line. And it's less than, so I'm going to shade underneath. So now you need to use and look at a different color or look at what you need to shade in. Where is the overlapping of red and blue? It'd be right here. So everything in this region would be points that are solutions to both inequalities. In the got it problem on the bottom of page 272, in the second section, we're doing the complete opposite. They give you the answer. They want you to write the system. So here, we're just going to write an equation for both inequalities. So let's start with the red one. Why? Well, because it's dotted, we're not going to have an equal to. And we shaded underneath, so it's going to be less than. So we need to find slope. So using my green, I see a point here, and a point here, a point here. So that means we're going to go down 1 to the right 2, down 1 to the right 2 is a slope of negative 1/2 x. And where does it cross the y-axis? At 1. The blue inequality is shading underneath, so it's also going to be a less than, but it will be also an equal to since it's a solid boundary line. Our slope here is going uphill, so that means I'm going to go up 1 over 2. So that's a positive 1/2 slope. Crosses at 1, so my inequalities will be y is less than negative 1/2 x plus 1, and y is less than or equal to 1/2 x plus 1. In the next section, we're going to solve word problems using a system of inequalities. The got it problem on the bottom of page 273 says that you want to build a fence for a rectangular dog run. You want the run to be at least 10 foot wide. The run can be at most 50 foot long, and you have 126 feet of fencing. What is a graph showing the possible dimensions of the dog run? Now, if you notice the gray box at the top, it says that you can solve or model many real-world situations by writing and graphing systems of linear inequalities. However, some real-world situations involves 3 or more restrictions. So you must write a system of more than 2 systems, which means at least 3. So here, we have a few things. The width has to be at least 10 feet wide. So the width has to be at least, which means it has to be greater than or equal to 10. The run can be at most 50 feet long, so the length has to be at most. So at most means it can't go over 50 feet. So that means it has to be less than or equal to 50 feet. Now we know we have 126 feet of fencing. What is a graph showing the possible dimensions of the dog run? So I have 126 feet of fencing. So that's perimeter. I have 2 lengths plus 2 widths. And we only have 126 feet, so we have to use less than or equal to 126 feet. So let's start graphing this. I'm going to draw my graph, and I'm going to make it so that I'm in quadrant 1, since you cannot have a negative amount of fencing. So I'm going to let let's say this is going to be my x, which is let's do my length for this, and w for my y. And it really doesn't matter what you use. So the width has to be more than 10. So if I count by tens, 10, 20, 30, 40, and so on. I'm going to use red for this. Width has to be more than 10. So if I draw my line, it's going to be a horizontal line. It can be equal to 10, so that's why I have a solid boundary line. And it has to be greater than or equal to, so that means I'm going to shade above. Now my length, though, my length has to be less than 50. So I'm going to use black for that. But it can be equal to, so I'm going to have a solid boundary line. Whoops, that's not on 50, but let's say it was. Less than, so I'm going to shade to the left. So if you're kind of looking, the overlapping region is this region right here. This is my overlapping region. Now to graph the next one, I'm going to solve it for W. You know what? No, I'm not. I'm going to use intercepts. So my L-intercept and my W-intercept, let's see, if I cover that up, 2L equals 126. That means this is going to be 63, and the width will also be 63. So I'm going to graph these up to 70. Put a dot on 63. Put a dot on 63. It's going to be equal to or less than 126, so it can be a solid line. I'm going to make this green. But it has to be less than. And if you plugged it in, plug in 0, 0, that would be 0 is less than or equal to 126, so that is true. So this region would be green. So what is the part that overlaps? The overlapping region, let's see, it's going to be less than the green. Has to be here. Whoops. I'm going to make this a little darker. Has to be above the red line, smaller than this green line. And now, wait a minute. Look where I'm going. Can we have a negative number of fencing? No. So it's only going to be this region right in here. Those are all the amounts of dimensions that I could use for lengths and widths to make my fencing for a dog run.